10% of these questions on the SAT, when it gets hard, always and it's gonna make it so much easier. 90% of the SAT questions are pretty easy and simple to master. But the other 10%, that's where you gotta get your hands dirty. No, not that kind of dirty. Let's keep it family friendly. What I mean by that is you're gonna have to get into the trenches, take 10, 50, 100 practice exams, get your butt kicked, and get your feelings hurt. And after going through all that, you'll realize what these 10% is all about. But there's one problem. It just takes way too damn long. I'm gonna share with you what these questions look like, how to solve them quickly, and most importantly, the insights you wanna know for each of these questions. Every question that we're going to go over and all the insights you need to know for all of these questions, I organized it nicely into a PDF, which you can download and print out by going to the pinned comment down below. Highly recommend you print it out and try it with me. By the way, guys, this is an advanced solution video, so I'm not gonna go over every single step by step. If you're not really sure what you're doing, this video is not for you. Go back to the other videos. So the first question, we're looking for the highest possible integer of n, right? And what does n represent? N is the y value of a solution within these two inequalities right there. So what most students end up doing is they try to plug and chuck numbers and realize that, oh, that's probably gonna take me too long and I'm not even sure if that's gonna be the right answer. So how are we supposed to approach these types, right? So when it comes to inequalities and you're dealing with multiple of them, then the first thing you wanna do is you wanna shade out, you wanna draw out and visualize what the question is telling you. So for the first inequality, we know it's y is less than or equal to 7x. So it's gonna graph something like this. And because it is less than, we are going to shade this portion right there. For the second one, y is less than or equal to minus 10x plus 4,000. Obviously, we can't go out 4,000, so we're just gonna roughly sketch it. That's the key. So 4,000, let's say it's about right there. Minus 10x, it's gonna go something like that. And because it is less than, we are also going to shade this portion right there. And when it comes to two inequalities, the solution is referring to the intercepting points, overlapping point between these two graphs. So which is going to be right there. And we know that every point that is inside this overlapping region is going to be a solution because it satisfies both of them. So m and n is any point that's in here, but we're looking for the highest possible value of what? The y value. So y goes up as we go up, and the highest y value is going to be right there, which is the intersection point between these two graphs. So essentially, the question is asking you to find out the y coordinate of the intersecting point. And at the intersecting point, because they are going to share the same y value, we know that these y's are going to be the same, which means we can now set them equal to each other. So if we do the math, we're going to look something like 7x is equal to minus 10x plus 4,000. And if we do the math, 17x is 4,000 and x is equal to 4,000 divided by 17, which is going to be 235.29. So what's the highest possible integer value? It's going to be just 235. That's going to be our answer. So the key takeaway from this question is whenever you're dealing with multiple inequalities and the question gets complicated, always visualize out, not just on these types of questions, but guys, 10% of these questions on the SAT, when it gets hard, always visualize out, draw out what the question is telling you, and it's gonna make it so much easier. And you're gonna get a couple hopeful hints on where to go next. So let's go to the second question. This question is super wordy. Not sure why. It's not the reading section, it's the math section. But here's what you need to know. Chicago's waste management company processed 28.4 million paper and 9.7 aluminum of waste. Of the paper and aluminum waste processed, 15.3% was paper and 33.1% was aluminum. By approximately what percentage was the number of tons of recycled aluminum higher than the tons of paper that was recycled? Okay, so the question itself is not very hard, but it's hard because one, super wordy, two, there's a lot of information that you have to process. So when it comes to these types of questions, guys, I mean, equation generation is going to be the most important thing, but a good habit to have is have all your works really, really nicely organized. So for paper and aluminum, right? For paper, we have 28.4 million and aluminum, we have 9.7, right? And of those, for paper, we processed 15.3, and then for aluminum, we processed 33.1%. And now we have to find out what the amount is so that we can compare them and see what percentage higher it was. So how are we going to do that? So for paper, we recycled 15.3% of that. So we can find out by multiplying the decimal version, 28.4 times 0.153. The amount is going to be 4.3452. And you always want to write out every single digit as much as you can. You don't want to round it in the middle. You want to round it at the end. Otherwise, your number is going to get messed up. For aluminum, 9.7 times 0.331, we're going to get 3.2107, right? And now, this is where most people get stuck. We ask ourselves, how are we supposed to find out how much, like what percentage higher this is? And here's a cool trick that will solve that problem for the rest of your life. See, let's look at this equation right here. 10 times 1.1 is equal to 11, right? If you're pretty decent with percent operation, we know that, okay, 110% of 10 is going to be 11, right? And because 110%, we know that there's going to be a 10% increase. So we know that 11 is technically 10% higher than 100, right? By looking at this equation right here, by having this equation, we know exactly what the relationship is between 10 and 11. And that's exactly what we're going to apply here, okay? We're going to make an equation. So 3.2107 times certain percentage, right? We're going to call it y, is equal to what? 4.352. And by finding out what y is equal to, we can find out what percent greater it is. So if we divide it, we're going to get 4.352 divided by 3.2107. We're going to get 1.35, right? Which means it's going to be around 1.35 over here. And we know that, okay, that is showing that 4.352 is 35% greater than 3.2107. We can now find out the relationship, which means our answer is going to be choice C. So when it comes to these word and complicated questions, the first thing you should do is you should very first have everything organized. It's not only a good habit for the SAT, but a good habit for the rest of your life and your career. Second, when it comes to percent questions, you definitely want to know how operation works. That's the bare minimum. But more importantly, you want to understand how to do equation generation so that you can find out the relationship between two numbers by setting up equations like so. It's just super handy. So let's go to the next question. The question says, given that 1 mile is equal to this, okay, and 1 liter is equal to that, 600 meters per liter is approximately equal to how many miles per gallon, right? So this question seems like a simple rate question, but it involves multiple steps. And when it does, you want to use something known as dimensional analysis, which you probably could have learned in chemistry, but probably forgot like 90% of it, like I did too. I had to relearn it again for the SAT. So currently, our relationships that we know is going to be what? 600 meters or 1 liter. But the question wants you to put it in terms of miles per gallon, right? So your final result should be something looking the units of miles per gallon. So how are we going to do that? So what we're going to do is we're going to convert unit by unit, okay? We're going to focus on converting meters into miles by going from meters to kilometers into miles, okay? And then we're going to do the same thing for liters. We're going to go from liter into gallons because the SAT gives you the exact relationship right here. So first, we're going to start with meters. And if you want to change meters into kilometers, what you're going to do is you're going to put it to the opposite side. It's at the top right now, so we're going to put it to the bottom. And the unit that we want, we're going to put it at the top. And then in between, we're going to put in their relationship. We know that 1 kilometer is essentially 1,000 meters. And same thing, kilometers and miles. Now I want to change kilometers into miles, right? So what's the relationship? 1.61 kilometers is 1 mile. And what ends up happening here is that mile is like variables. They get crossed out. Kilometers get crossed out. And at the end, you are left with not M, John, what the heck? You're left with miles. So that's going to be your final unit. And we're going to do the same thing for the liters. So we're going to do liters to the opposite side. And then we're going to put gallon at the bottom. So we know the relationship is 1 liter is going to be 0.264. So what happens with the units now? Liter gets canceled out. Liter gets canceled out. And at the end of the day, you are left with miles and gallon, which is exactly what we're looking for. We're looking for miles per gallon. So to get to the answer, you pop these bad boys into the calculator and then that's it. So 600 divided by 1000 divided by 1.61 divided by 0.264. Okay, that's going to give us 1.411, right? So that's essentially 1.411 miles per gallon. Okay, that's the relationship. So our answer is going to be 1.411 or how many ever digits is going to fit into your answer key. So dimensional analysis is like your parents. You don't think you really need them, but once you go off to college and you have to do everything by yourself, you realize that you are. So take a second and text your mom and dad that you love them. And let's go to the last question. In the XY plane, a circle centered at 10,4 with a radius of 6 contains a point x0. What is the potential value of x? Okay, seems like a really simple equation of a circle question, right? Not really. So if you know how equation of a circle works, if you don't, you can check it out here. By looking at this information, we can come up with the equation x minus 10 squared plus y minus 4 squared is equal to 6 squared, which is going to be 36. From this, we know that the center is located at 10 and 4, and the radius is going to be just 6. But how are we supposed to find the value of x? That is kind of sitting inside, right? Well, as I said previously, when it gets hard, visualize. So let's visualize what this looks like. 10, 4. So 10, 4 roughly right here. You don't have to be near DiCaprio for this. You just need to sketch sketch it out roughly. And if you got the question right because you drew it to scale, the chances are you probably spent too much time on it and you did it the wrong way. So we're looking for value of x, and the point is at x is 0, y is going to be 0 here. So your graph doesn't have to be amazing, but it has to be like half decent. So let's kind of move this down a little bit so that it actually makes sense. Okay, so let's say your y is going to be 0 here somewhere and your x is going to be here somewhere, right? And you could pick like 3. Looks like it's inside, but obviously not the most accurate drawing. How would you know if it's inside or not? Well, one thing that you have to understand is that this portion, we were taught that this represents the center, right? But what you have to realize is that the value that you get from here represents the distance from center. So we know that this point over here is going to be 10, 4, right? So let's say we use a random point of just going up 6, right? Then our point is going to be 10, 10, right? Because the radius is 6, if we move up 6, then we are going to be exactly on the circle. So if we plug this point into this equation, what are we going to get? We're going to get 0 and 6, right? So we're going to get 0 plus 6 squared, right? That's going to be 36, right? And if we square root this, we're going to get 6 as the radius, or 6 is the distance from the center. This point over here, that's currently 10, 10. We know that the distance between the center and this point right here, the distance is going to be 6. That's why if you plug in every single point that is on the circle, you're always going to end up at 36, because the distance from the center to all of these points is always going to be 6. That's how a circle is formed. So what that means is if this side is less than 36, that means you're going to be inside the circle, because your distance is not going to be so far enough to be outside of the circle or on the circle. And the opposite is that whenever this side is going to be what? It's going to be greater, then what happens? You're going to be outside, because your distance from the center to whatever point is going to be greater than 36. If it is at 36, it's right here. If it's less than, it's inside. If it's greater than, it's on the outside. So for us to find the point where it is inside the circle, we just have to make sure that our left side is going to be what? Less than 36. And SAT makes it pretty easy for us. So if we plug in x over here and 0 over here, we're going to get x minus 10 squared plus 4 squared, right? And we know that it has to be less than 36 in order for it to be inside. So x minus 10 squared is less than 20. And if you have a terrible addiction like I do, when you see that, you just want to expand it out. But don't do that. It's a waste of time. Instead, think of the value of x where the final result is going to be less than 20. So we know that 4 squared is going to be 16. So what gives the inside as 4? We just need it like, I don't know, 6. So if we do 6, we're going to get 16, which is going to be less than 20, which means it's going to be inside the circle. So what is our answer going to be? Our answer is going to be 6. It might take you a second for this information to click, but once it does, you will never miss these questions ever again. And if you want more of these advanced questions and insights, check out SAT Math Solidifier in the pinned comment. And most importantly, if you're only missing these hard questions, you just got to get your hands dirty, learn all the lessons, learn all the insights, and do more practices.